Welcome to the Explainer, everyone. Today, we are stepping right into the high-stakes world of network security. We're going to be talking about the ultimate shield, protecting your data. And, more importantly, the invisible threats that are constantly trying to slip right past it. So, if you've ever wondered how modern firewalls handle the absolute mountain of encrypted data flowing across the globe every single second, well, you are exactly in the right place.
It's a pretty chilling thought, right? What if the biggest attack on your network is actually happening right now, but you literally just can't see it? In the world of cybersecurity, ignorance is absolutely not bliss. It's a massive liability. You see, attackers know that if they can just hide their malicious activities inside normal-looking encrypted traffic, most security systems will basically just wave them right through the front door.
Okay, let's dive into this. A prime example of this invisible danger is the infamous Log4j vulnerability. Now, this was a critical flaw found in a wildly popular software library, one used by millions of applications worldwide. What made it so completely devastating was that attackers could use it to execute remote code, steal credentials, and compromise entire systems with surprisingly little technical knowledge. And here is the real kicker. A huge chunk of this malicious traffic was happening inside encrypted connections. Without the ability to look inside that encryption, a firewall simply cannot see the attack happening. It just sneaks right past in the dark.
To understand how we fight back, here is our roadmap for today's Explainer. We're going to start by looking closer at this invisible danger. Then we'll introduce the ultimate solution, which is decryption. From there, we'll explore the two main ways we use it: protecting users with Forward Proxy and protecting servers with Inbound Inspection. After that, we'll cover the unique challenges of the cloud and the advanced tools used to secure it, before finally wrapping up with the absolute foundation of modern security.
So let's kick things off with Section 1, the invisible danger. These are the threats hiding right in plain sight.
The core issue we're facing here is the attack surface itself. Encryption is fantastic for privacy, obviously, but for a firewall, it basically acts like a blindfold. If a firewall cannot inspect the actual content of the traffic, a massive array of attacks can advance completely undetected. That's exactly why decryption is not just visibility. It is the real capability to detect invisible threats. Think of decryption like a light switch. The moment you turn it on, the whole scenario changes. The firewall goes from just guessing to actually knowing. It can inspect the communication, spot those malicious patterns, and block the attack before it ever causes an impact. This before and after difference is exactly why visibility is paramount.
Moving right along to Section 2, the solution: illuminating the network. To implement this critical visibility, operating systems like PAN-OS rely on specific decryption frameworks. They don't just blindly open everything up, right? They use highly structured methods to securely intercept and inspect traffic. And there are two primary modes we're dealing with today. First, we have SSL Forward Proxy, which is all about protecting your internal users when they go out to the internet. And second, we have SSL Inbound Inspection, which basically flips the script. It protects your internal servers from unknown external users coming in. Let's break these down one by one.
All right, Section 3, protecting users. This is all about securing that outbound journey.
This method is super common in corporate environments. It's used to protect employees, IoT devices, and operational networks and branch offices when they try to access external resources. Now, to make this work, the firewall acts as what we call a man in the middle. Think of it kind of like a highly trusted bouncer at the door of your network. When a user tries to access a secure HTTPS website, the firewall steps in. It intercepts the connection and acts as this trusted intermediary. But to do this without breaking the secure connection, it has to generate a brand new certificate for that site on the fly, which it then presents to the client.
Let's see how this builds systematically, so it doesn't get too overwhelming. First up, your computer, the client, initiates a secure TLS connection to an external site. Step 2, the firewall intercepts this initial handshake. Then, in Step 3, the firewall independently connects to the real external server, receives the original certificate, and validates it according to your company's security policies. Step 4 is where the magic trick happens. The firewall generates a dynamic impersonation certificate based on the original, signs it with a trusted internal authority, and hands it right back to the client. Finally, in Step 5, the keys are exchanged. The firewall now maintains two completely separate connections and has everything it needs to decrypt, inspect, and re-encrypt the data in real time. And the best part? The user doesn't notice a thing.
Now for the other side of the coin. Section 4, protecting servers, securing the data center.
So this is a completely different scenario. Instead of internal users going out to the web, we have unknown internet users coming in to access your hosted applications and data center servers. The firewall is still acting as an intermediary here, but there is a massive, absolutely crucial difference. It uses the real server certificate. Because you actually own the internal server, you don't need to generate some fake impersonation certificate. Instead, the network administrator just imports the actual server's private key directly into the firewall.
So the flow looks a bit like this. Step 1, an external client tries to connect to your internal server. Step 2, the firewall intercepts this and simply presents the legitimate, real server certificate to that external client. In Step 3, it establishes a separate, secure connection with the internal server itself. And finally, in Step 4, just like before, the traffic is decrypted, inspected for web attacks, and then re-encrypted before it ever even reaches the server. This is absolutely critical for stopping attacks dead in their tracks before they can touch your sensitive data center applications.
Moving into Section 5, Cloud Challenges. Expanding the perimeter.
Public cloud environments introduce a whole new layer of complexity, often requiring us to combine decryption with web application firewalls for even deeper protection. I mean, you have applications exposed to the internet facing constant attacks, and often these apps have unpatched vulnerabilities. But what's really interesting here is a feature called decryption mirroring. You see, sometimes just inspecting the traffic on the firewall isn't quite enough. You actually need to send that data to specialized external tools. Decryption mirroring allows the system to create a raw, exact copy of the already decrypted traffic and send it out for analysis. And it does this entirely out of band, meaning it doesn't slow down or impact your main network flow at all.
The benefits of doing this are just huge. You can send this mirrored plain text traffic to external systems for deep forensic investigations, compliance audits, and crucially, data loss prevention, or DLP. Without this level of visibility, an attacker could silently exfiltrate highly sensitive data out of your organization inside an encrypted tunnel, and you literally would never know. Mirroring ensures your specialized tools get the raw data they actually need to stop a catastrophe.
Now, another incredible tool in this arsenal is the Network Packet Broker, or NPB. A packet broker actively manages network sessions and forwards traffic to multiple external security tools. So instead of just sending data to one single place, it creates a highly coordinated, sequential chain of inspection.
So why do we need this? Well, it's absolutely ideal for highly regulated environments. Think finance, government, where a single layer of inspection just isn't legally enough. The NPB can handle encrypted, decrypted, and even unencrypted traffic, routing it seamlessly through all necessary security tools. But the most important feature here is the last one. It actively guarantees that all traffic is fully re-encrypted before it is finally delivered to its destination. That way, the integrity and security of the communication are never, ever compromised.
And that brings us to our final section, Section 6, the foundation of security, bringing it all together.
When you take a step back and really look at all these flows and architectures, a very clear picture begins to emerge. And the crucial point is this: decryption is not an add-on. It's not just some optional feature you can toggle on if you feel like it. It is the essential foundation of literally any modern security strategy. Without it, advanced attacks are going to simply walk right past you in the dark. But with it, you have the real power to identify, analyze, and block those threats before they can do any damage. By understanding the different modes and flows we've discussed today, you can build a rock-solid base to implement decryption efficiently and securely in absolutely any environment.
Which leaves us with one final thought to ponder today. Take a hard look at your own architecture and ask yourself, is your network really protected, or are you just trusting in the dark? It might just be time to turn on the lights. Thank you so much for joining me on this explainer, and keep asking the right questions about your security. Catch you next time.